In this video, we'll see how the stresses are induced in composite section. Composite section is nothing but the section which is made up of two or more materials. So here we are having the section which is made up of copper and steel. So this is the hollow circular section. Inside diameter is di, and that is equal to outside diameter of the steel bar also. So inside diameter of the copper tube is equal to the diameter of the solid steel bar. T is the metal thickness. So we can say that DO will be equal to DI plus 2T, because this T and this T, that is 2T. Now let ACU is equal to area of hollow copper tube, and that is equal to pi by 4 DO square minus DI square. AST is equal to area of solid steel bar, that is pi by 4 D square, because DI is equal to D. Now P is the actual load in Newton. Now this P is not shown in this figure. The conditions which we'll have to use is the elongation of copper, that is change in length of copper is equal to change in length of steel, or elongation in steel rod, because they are acting as a one single member. So we can say that PL upon AE of copper is equal to PL upon AE of steel. So length is same. So if length is same of the composite section, we can cancel out this particular length from both the sides. So it is P upon AE of copper is equal to P upon AE of steel. Now this force upon area, P upon A, is nothing but stress. So sigma upon E of copper, again over here P upon A is stress, that is sigma upon E of steel. So it is sigma copper divided by E of copper is equal to sigma ST divided by EST. Cross multiply these two terms. So sigma Cu into EST is equal to ECU into sigma ST. So we'll get the value of sigma ST in terms of sigma Cu. So it is EST upon ECU into sigma Cu. So sigma Cu EST, transfer this ECU on the other side, it will be in the division. So here it is in the multiplication, it will go on the other side as division. Now total load will be load taken by copper plus load taken by steel, and we know that force is equal to, or load is equal to, stress into area. So we can say that it is stress into area of copper plus, in place of P, it is stress into area of steel. So it is sigma Cu into ACU plus sigma ST into AST. Now we have calculated the value of sigma ST over here, that is sigma Cu EST divided by ECU. So that value we can substitute. So in place of sigma ST, we can substitute this entire value. So that value is already substituted over here. Sigma Cu is common from both this term. So if you take that term common, then it will be ACU plus EST upon ECU into AST. Or we can say that sigma Cu will be equal to P upon this entire bracketed term, that is ACU plus EST upon ECU into AST. Once you know this particular value of sigma Cu, you can easily substitute that value over here and you will get the value of sigma ST. So in this way we can calculate the stresses which are induced in the composite section. Now let us see one similar example on this. Suppose we are having a brass rod of 250 mm length and 20 mm diameter, and it is fixed inside a steel tube of 40 mm external diameter and 20 mm internal diameter of the same length. The composite bar is subjected to axial pull of 150 kN. Find stresses in each metal. If modulus of elasticity for steel is 200 GPa and for brass it is 110 GPa. So brass rod, it is the solid rod, length is 250 mm, diameter is 20 mm, E brass is 110 GPa. Convert GPa into MPa by multiplying by 10 raised to 3. For steel tube, length is, again the length is same, so it is 250 mm. External diameter is 40 mm, internal diameter is 20 mm. Modulus of elasticity for steel, it is 200 GPa. Convert GPa into MPa and P is 150 kilonewton, that is 150 into 10 raised to 3 Newton, converting this kilonewton into Newton. So we are having brass rod which is enclosed inside the steel tube. So again we know that dO is equal to di plus 2t. The values of dO, di and d, they are all given in this case. Now we have to apply the conditions. So suppose AST is equal to area of hollow steel tube, calculate that particular area, substitute DO is equal to 40 mm and DI is equal to 20 mm and make the calculations. So area of steel rod, area of steel tube, hollow steel tube will be 942.477 mm square. Then area of brass, solid brass rod will be pi by 4 d square. Value of d is nothing but di, and that is 20 mm. So in place of d, we have to substitute 20 mm. So pi by 4, 20 square, that is 314.159. Now we know that condition is elongation in brass must be equal to elongation in steel because it is acting as a single bar. So PL upon A of brass is equal to PL upon A of steel tube. Length is same, so that length will get cancelled from left hand side as well as from the right hand side. So it will be only P upon A of brass is equal to P upon A of steel. Now this P upon A is nothing but it is sigma. Here also P upon A is nothing but sigma E as it is. So it is sigma upon E of brass rod is equal to sigma upon E of steel tube. So sigma brass divided by E brass is equal to sigma steel divided by E steel. Cross multiply over here. So it is sigma BR into EST is equal to sigma ST into EBR. So sigma ST in terms of sigma brass will be equal to, transfer this E brass on this side, it will be in the division. Now this ratio is known as the modular ratio, that is the ratio of two elastic moduli or two modulus of elasticity, and this value is always greater than 1. So EST is always greater than EBR. So the ratio of two modulus of elasticity is known as modular ratio, that is M. So it is M into sigma BR is equal to sigma ST. Now total axial load will be equal to, some part of that axial load will be taken by brass rod plus some part of the load will be taken by the steel tube. Now load or force is equal to stress into area, because stress is force upon area, so force will be equal to stress into area. So sigma brass into area of brass plus sigma ST into AST. Now this sigma ST is nothing but M into sigma brass. So in place of this sigma ST, we have substituted M into sigma brass. And now take this sigma BR as common. So it is ABR plus M into AST. So sigma BR will be equal to P upon ABR plus M into AST. Substituting all the values in this formula, that is M is nothing but EST upon EBR. So and all the other values, you will get the value of sigma brass as 73.98 Newton per mm square. So you can see value of M we have already calculated, that is the modular ratio, larger value of E divided by smaller value of E. So if you substitute the value of E steel divided by E brass, that value comes out to be 1.818. So you can substitute that value over here. Value of P is known, ABR is calculated, and AST is also calculated. So we'll get the value of sigma brass as 73.98 Newton per mm square. So sigma ST will be equal to M into sigma brass. So substitute the value of M, that is 1.818, and sigma brass is 73.98. So the value of stress induced in the steel rod, in the steel tube, comes out to be 134.5 Newton per mm square.